you were telling me about a serendipitous event, about a device that you had designed that ultimately saved your daughter's life. And I would love to hear the story about that.
So I didn't exactly design the device that saved her life, but we did have wonderful opportunities to collaborate with the designers of the device
Gotcha.
for their power transmission needs. So, robots have so many systems, mechanical systems, electrical systems, um, lots of software, lots of infrastructure around them, but it's gears that make the thing move. So in the larger joints of a robot, you'll have like um, cycloidal gearboxes or harmonic gearing, they call it. It's strain wave gearing. And where CGI focuses is on small power transmissions, more like the end effector stuff, so a lot of the ends of the arms, and that's where we really shine. Well, we've had, like I said, wonderful opportunities to work with some of the world's best robotics engineers, and one of the devices that we had a hand in designing the gears for was used in an operation, a procedure that my daughter had to have. So she unfortunately had a condition called it's called placenta previctus, I believe. It's when the placenta attaches to the wrong spot in the uterus, and then it grows at an exponential rate, trying to find the nourishment that it's looking for, and ultimately the infant becomes unviable and not treated, kills the mother. So the doctor said it was a pretty serious situation. It was a circle the wagons, gather the family type of procedure. And typically it requires a transfusion of lots and lots of blood, liters and liters of blood. It's very messy procedure. But after all was done, he was able to use the robot, 100% robotic on the procedure. And he seemed to think that was the first time ever that had been done 100% robotically. So they made history that day. And so I got to talk to him and told him that, on that particular system, you'd have a hard time, you couldn't put your hand on that robot without being close to something that CGI manufactured, or that if it's gears, I designed it myself. So in sort of some way, yeah, it comes right back to it. My daughter was happy that we were part of the solution, and
I imagine.
yeah, no, it was terrific.
That is amazing. That's
Yeah,
such a good story.
She healed quickly, much faster than people who normally have that procedure done. So it was minimally invasive. The doctor said even the previous time that he performed that same procedure, he was forced to, I forget the terminology, I believe it is abort and convert, where they have to remove the robot, open up the patient, and go in. So that was the first time he was able to do the whole thing. 100% robotic.
That is absolutely amazing.
Take quite a bit of pride in the fact that CGI was able to be part of that.
What do you know? What part, what CGI part was in the robot?
Absolutely, I do. So we manufacture gears that go on both the surgeon side console as well as on the patient side. On the patient side, the gearboxes that most directly a part of are the ones that drive the tools.
Okay.
Yeah, so the last thing before the tool that touches the patient is the tool driver. That's where his gearbox is.
So for that piece of it, did you design that piece?
So the interfacings, or we did collaboratively with their engineering team, their design engineering team, but as the power transmission components, so the selection of materials, the selection of heat treatment, that sort of thing was all done by CGI, done by me.
Was there any inspiration to have that heat treated part? Or I mean, you could have not foreseen how that was
Sure.
going to be used. So what was the inspiration for that particular piece of that puzzle?
So, a lot of the stuff we do is, we do some products that are of industrial nature, and we do some that are, much more delicate, much more sensitive, like the ones we're talking about now. And those they really have to be highly engineered, right? So the dimensions are small, the parts are small, but the amount of effort that goes into them is incredibly high. It's not a quick process. And we take that stuff very seriously. One of the mantras we say is, somebody you love, may receive treatment from one of these devices. We treat them with an awful lot of personal care, right? Well, then of course now it comes down to, when I used to joke and say, what happens if your mom's having surgery? right? Well, now I got to say my daughter's had surgery that was necessary for her to survive. And
Was there a moment that you weren't sure if the device, or that device or others, wouldn't perform as you had intended? And can you describe that feeling, if you had that feeling? And then how did you overcome that feeling?
so my only concern was anything that could go wrong in any surgery, really. Never had a concern about the components failing or something like that. You know, the surgeons are all highly trained. They're the best in their field before they learn how to use the robot. The robot just makes them that much better. So I'm also less concerned about that, and just more things that can happen during an operation. As far as the gears performing, no, I won't blink an eye on that.
Okay, so let's talk a little bit about the design process. What was the design process like, and how did you ensure that the device met safety and performance standards?
Sure. So again, through material selection, heat treat selection, through careful, what's the word? You know, every company has their secret sauce when it comes down to what to do. So the way we do our profile shifting on our gears, having an understanding of the application, you know, if they're going to be, you know, it's a multiple oscillations or one direction use, that sort of thing, allows us to design in such a way that we can meet those goals. So some of the things we have to take into consideration during design are, and might seem like a silly one, but noise. A noisy gearbox, it's very distracting. It's not good for the instrumentation. So you have to have very smooth performing gears. Another one is to tailor the gears in such a way that they don't wear prematurely. These aren't gears that are greased by or lubricated, by an oil bath or something like that. This is a one-time lube for life situation, and so you have to carefully choose that sort of things. I mean, we take it as life or death.
It is life or
It
death,
is life or death.
for sure. So I would imagine that you get a lot of feedback from the medical professionals. And can you tell me a little bit about that, how you incorporate that feedback from the medical professionals during the R&D process? I know you just talked about the noise and that sort of thing, but are there any other factors specifically from the medical professionals themselves?
So I haven't heard anything from physicians who've used it. I haven't had any feedback from them, but plenty of feedback from the engineers and the clinicians that they have at these various surgical robotics companies. Such as they go through an iterative process when it comes to design. You know, they understand that things have to be, you have to take more than one trip through the design to make sure that it's performing the way they want. And they go through multiple, call them V&V testing, verification and validation, and then they go, you know, human trials and stuff. So there's a lot of stuff before the design is considered complete, before they freeze the design in place. There's a lot of testing they go through. So we do in the design phases, going through those various iterations, we will get feedback like it needs more. Actually, they never need more of anything. They want it to be less friction, more efficient, that sort of thing. And so we can do those things through our manufacturing processes and through the design process. So we're very lucky. So I can throw some crazy gear designs through our manufacturing department. It gives them fits, but we've been successful.
Yeah. So let's talk a little bit about the technical specifications. So is there anything that distinguishes your parts from other parts that are used in the same types of applications?
Well, I would sure like to think so. As far as design-wise, I think we do a top-notch job. I'm sure there are lots of other engineers out there who are, in the gear industry that have the wherewithal to do the designs, and other places they can make the parts, but we've got the right recipe. And it's been working for us. And these robotics engineers, they're not bound by convention, always pushing boundaries. And so that gives us an opportunity to change and grow along with them. And we learn a lot along the way that we can apply, the next time we hit one of these. And so I've always been an engineer who, when I know the rules, I learn how to bend them without breaking them. And then, of course, those things go through, test after test after test to be verified. And so we call those, just another tool in the tool chest, to use the next time a design comes around. And that has worked for us not only in the medical industry, but lots of others, including semiconductor, aerospace, defense. We apply those same things.
So, how did this experience change your perspective on medical devices and their impact on patients, if it even did? I mean, I would imagine there was some sort of shift in you, but
Well, I've got to see in the orthopedic space. I've got to see some. I've been to labs where they have cadaver knees and hips and things like that, and see just how brutal some of those things are when they do practicing for a hip replacement or something like that. And the impact there is like, wow, that looks like it really hurts, right? So we got to make sure that these tools that we design are going to make it through. They're going to survive not just the procedure, but be able to be cleaned and autoclaved and used again and again and again. And like I've said before, what if your mom had to go in for a hip replacement? You'd want to make sure that she had the doctor had the best tools in his hand. Same thing when we moved on and began expanding into the robotic spaces. It's much more serious. There's a lot more going on. At first, it was kind of are robots going to be a thing? Yeah, they're going to be a thing, right? Now they're everywhere. They're doing everything, and what the new things they're able to do is incredible. So, some of these tools are, from what I understand, they're 6 times more articulate than a human hand. So, imagine now what you can do. So, and minimally invasive. You're no longer opening huge ports in the body. It's some of these systems go through a single port. So no longer multiple holes in the trunk. It's pretty amazing. And again, so my personal experience now with my daughter having been on the patient side of such a device, it brings it home for me for sure.
what is your take on AI, the use of AI with the medical device manufacturing industry?
I have to say I'm undecided.
You're not alone.
Yeah, I am a fan of those 80s and 90s sci-fi movies, and robots thinking for themselves. It's going to happen sooner or later, but I'm undecided. There's already great things that are happening with artificial intelligence, and it won't be long before they're in the medical space as well. So it'll be interesting to see what happens.
How do you ensure that patient safety is always top priority in your designs?
Well, you over-design to a certain extent, but you have to be careful how much what they call a safety factor or a service factor you put into any design, especially on a robotic arm, because the adding safety factor or adding whatever, making the gears bigger or stronger or something like that adds cost and it adds weight. And when you have that extended out of the proximal end of, the distal end of a robotic arm, all that weight has to be borne by the rest of the structure, making it larger, making it more expensive. So we take into consideration the best materials, the best profile of the gearing to do the job in a very small package. Most of the gearboxes we're talking about are less than an inch in diameter, roughly 20 millimeters, and that would be a big one. The smallest gearbox that we do now is 10 millimeters in diameter. It's a true planetary gearbox.
So are there any emerging technologies or trends in the medical device manufacturing industry that excite you? And talk about how the future engineers can use that.
And I think in the future we're going to see a lot more additive manufacturing, right? We'll see more 3D printed things happening. Right now the precision isn't there. You still have to take those components and machine them again afterwards to add the precision features to it. But that's going to get better and better. And I think as long as those things continue to improve, engineers are going to have many new tools, new capabilities at their fingertips. We're making pretty good use of technology that we have today. Everything that we do is machined. We don't do any additive manufacturing for production at all. We use it for some tooling and picturing and that sort of thing, but nothing that's going to be used specifically medically or anything like that. I think that those will continue to improve into the future, probably after my time. But truth is, things are moving so fast nowadays. Technology is moving so fast. Maybe it'll be in my time we'll get to design and work with those sorts of systems.
Oh yeah, I've seen a lot of innovations and just since last year.
Absolutely.
In a year, a lot has changed. So
AI is terrifying, and those kind of things into the future, they will happen. There are software suites available to engineers where you can just tell it what you're envisioning, and it will do all the work for you. I worry that will take away from some of the brain power.
We have to always remember that AI it came from our brains, and it's just a faster way to compute it.
True.
And so It is scary, though. I am not going to disagree with you on that at all. We don't know what the future holds. So, is it going to be like iRobot? I don't know.
Right.
So, all right. Well, I thank you for your time. How is your daughter doing these days?
Wonderful. Spoke with her this morning and let her know I was going to be talking to you. She was excited, actually. She doesn't mind at all. Wanted her story to get out.